There is a terrible and strange number, a number that has been on the verge of causing disasters and deaths, a hidden number in our lives, and that today we come to unmask. 2,147,483,647. Let's discover its terrible power. The truth is that if one looks at it fondly, 2,147,483,647. It's a nice number. As you have noticed, it is probably a prime number. Moreover, it is a Mersenne number, and on top of that it has the honor of being one of the only 4 double Mersenne prime numbers known. I remind you that a Mersenne number is a number of the form 2 raised to p-1, with p prime. Some of these are prime and some are not. For example, 2 raised to 5-1 is 31, and 2 raised to 11-1 is 2047, which is obviously not prime. 23/89. A double Mersenne number is a number of the form 2 raised to 2 a la p-1, that is, 2 raised to a Mersenne number -1. Of these, some are prime and some are not. In fact, only 4 of these are known to be primes, which are the Mersenne double primes, and it is not known whether there are more or not. The fact is that 2 raised to 31-1 is a double prime of Mersenne, the value of which is precisely 2,147,483,647. But don't get too close to it. It's a terrible number, no matter how much pedigree he has. And to know the reason, we have to travel to the depths of your computer or your mobile or cell phone or the device with which you are watching this video. You already know that computers are managed with ones and zeros. Absolutely everything in them is encoded with ones and zeros. For example, whole numbers, the numbers we use to count, the numbers of a lifetime, the positives and negatives. We encode those numbers in binary notation with ones and zeros, and then the computer can handle it. When we program the computer, it saves each data we give it in a format, whatever it is, that says how much each data occupies and how it is encoded. This is what we call a data type. For example, a data type is integer. Most computers nowadays store integers so that they occupy 32 bits and encode them in binary with a system called 2's complement. We stopped a little. I'll tell you about it. The numbers in 2's complement start with 0 to indicate that the number is positive or by 1 to indicate that the number is negative. For example, to encode the 8 using 32 bits, I keep it on my computer like this. If you don't remember how the binary system works, watch the video we made in deriving on the subject. I leave the link in the description. That's okay, the positive 8, but what about the -8? Would it just be to put a 1 at the beginning? Well, it would be an alternative. But for efficiency reasons a slightly more complicated mechanism is used. The 2's complement of the 8 is calculated, and it is done like this. We start from the 8 in binary with 32 bits in this way. Now we turn ones into zeros and zeros into ones. It looks like this to us, and now we add 1 to this number. I remind you that in binary 1 plus 1 is 0, and I take 1 to the next figure. So the result is this, and it's the 2's complement of the 8. That's the representation of the -8 with 32 bits. Check it out if you want, and then when you learn, play with your friends to make the complement to 2 of many numbers. They are going to hate you very dearly. Anyway, to which we come, what is the largest positive number that we can encode in this system? Well, since it has to start with 0, the first digit will be a 0 and the rest all ones, like this. And how much is that worth? Well, a binary number with n1 is worth exactly 2 to n-1. Check it with n equal to 1 or with n equal to 2. Since here we have 31 ones, that is, the 32 bits minus the initial 0, that number is exactly 2 to 31 minus 1, that is, 2,147,483,647. The fateful number. Your character fateful is because if we have our entire encoded with 32-bit and we want to have things beyond 2,147,483,647, we will have problems, because if we add 1 to its binary representation, we obtain that this binary number plus 1 is equal to this. And if we keep adding 1 we are going to go at least 1, at least 2, and so on, it spoils everything. It's like when on the odometer of a car we turn the 9 and that happens. Has any computer had problems because of that? 14th of September, 2014, the control tower of the Los Angeles airport loses contact with 800 aircraft. Imagine the panic and tension of the moment. They could see them on the radar but couldn't communicate with them. Luckily there were no accidents, although there was some dangerous situation. 600 flights were cancelled, another 400 suffered delays. Thousands of people were affected and economically the losses were millions of dollars. And who was to blame? The number 2,147,483,647. Indeed, or rather his older brother, the double of 2,147,483,647. Calculate it mentally, dare to do it. Why was he to blame? It became known later that the time control of the computer system of the Los Angeles control tower stored the number of seconds in 32 bits, only in positive numbers. That's why the double of our favorite number, and on the 14th of September of 2014, that number of seconds was exceeded. The system turned over the counter. The system was stopped until the problem could be fixed. A few hours of real chaos passed at the airport. If you dive a little on the internet looking for problems caused by 2,147,483,647, you will find many examples. Even in the League of Legends, there was a trick based on this terrible. When computers will be smaller, these things also happened. Ask who reached the mythical level 256 of Pac-Man, that if you save the numbers with 8 bits, the largest integer is 255 and from there the problems begin. Even the almighty YouTube had a problem because of our favorite number. There was a video a few years ago that was about to reach 2,147,483,647 views. If the accountant had turned around, it would have been a disaster and an embarrassment. Luckily, someone noticed and raised the alarm. What they did was change the encoding of the integers from 32 bits to 64 bits on all systems, which solved the problem. 2 to 64 minus 1. It's a huge number. Are you curious to know which is the video that had that piece of record of visits? No less than Gangnam Style, which at the time of recording this video has almost 4 billion views. I'm going crazy. You can see that taking those little things into account when coding our information on computers is super important, because if they don't appear terrible numbers that ruin everything. Share this video to see if we get to 2 raised to 64 minus 1, that we can. Deriving style.